Hello everyone, today we are going to solve this problem LeetCode284 move 0. So given the example, let's say, here's the example here. So given an integer array names, move all zeros to end of it while remaining the relative order of the non-zero element. So in this question, that means that we only care about the order of non-zero element, but we don't care about the end of. So because we move all the zero to the end, we just maintain the relative order of the non-zero elements. So you must do this in place without make a copy of the array. So for this question, what we do, here is the example. So the input is the nums 0, 1, 0, 3, 12. And then after we move all the 0 to the end, and then the output it should be 1, 3, 12, 0, 0. And for the example of nums equals to 0, then it's going to be 0. Okay, this is a problem. So for this problem, if we're trying to do in place, so let's give a longer example. The example for this problem in this in here is too short. Let's give another one. This what I made this example. So for this one, because we are doing in place, so what we do? So first, I'm trying to actually define a variable called the size. Okay, so and then we are trying to explore the array. So the size, we are trying to keep a windows. So all the elements before the size, that means all the elements on the left of size, they are 0. So after it can be non-zero. Okay, so define the size. So the size is the number of zeros. Okay, let's do this. Here is the size. So we have another variable. Another variable is I. I is kind of an explorer. Okay, so I is explorer. Okay, so whatever. Okay, so let's start from this. So initially the size equals to 0 and I equals to 0. So if the nonce I equals to 0, that means here, if it equals to 0, the size plus plus. Remember, size is the number of 0, right? So, I mean, if it's 0. But in this case, it's not. So, if it's not 0, then we swap number I. Number I here is 1. And also swap with I minus size. Because the size is the numbers of 0, I minus size is gonna be the numbers of non-zero. So the insert position will be numbers I minus 0. I will show you later. So I minus size is the numbers of non-zeros. Okay, so the insert position will be numbers I minus size. Okay, so let's try to solve this problem. So the first element, nums I equals to 1, is not equal to 0. Then what we do, we swap I minus size and numbers I. So in this problem, I minus size is 0. So it's going to be swap 1 and 1. So it will be still this position here. And then what we do, we I plus I advance to here. So we check numbers I here is 2. If equals to 0 or no, so it's not equal to 0. So what we do, we swap I minus size and and the size. This is what we do. Swap. Okay. Okay, so in this case, I minus size, the size is 0, is still I, and that means this one swap by itself, and then I plus plus. This one is not 0, no, not equals to 0, then I minus size 0 still is I, so the numbers I swap itself. And then I plus plus, and now I equals to 0. When I equals to 0, so size plus plus. Why? Because size actually is the keeping the number of zeros. Right now we have a one. We have 1 0 now, so that's why the index here is a. It's not index. We should not actually put the size here. What we do? Let's do this way. I think this is much better. Okay, let's do this. Size now equals to 1, okay? And then what we do, we if equals to 0, what we do, size plus plus, and then I plus plus. When I plus plus, the numbers I equals to 4, 4 is not equals to 0. So in this way, we swap I minus size with I. I is 4, numbers I is 4. And I plus minus 1 is 0, 1, 2, 3, 4, and 1. 4 minus 1 is 3. So 0, 1, 2, 3. So we swap this 4 with this 0. Okay, and then we I plus plus, check this one is not equals to 0, then we swap I minus size. Because the size is 1, so the windows between size and I, that's the number of non-zeros. The number of non-zeros. So that's why when we insert, we will insert the numbers I minus size, because we already have I minus size number of non-zeros, and then the next one is gonna be I minus size, because we have index 0 here, so that's why 0, 1, 2, 3, 4, 5, and this one is 1. So 5 minus 1 is index 4. So 0, 1, 2, 3, 4. Yeah, it will be here. Because we have 4. We already have 4. The numbers of non-zero. So the next one will be this one. So in this way, here is 5. Here is 0. And then I advance. Nonce I equals to 6, 6 not equals to 0, then we swap I minus size with the 6. So in this case, it's gonna be 6 here, 0 is here, and I advance. And after I advance, here is the nonce I equals to 0. In this way, size plus plus. And then, because we record, we have 2 numbers now. These 2 numbers. This is 0, 1, 2. Yeah, so there's 2 numbers. And then we advance is equals to 0. Then we size plus plus. And then I plus plus. I nonce I equals to 3. And then 3. Here is a 3. So because here is a 3, what we do? We swap I minus size. So in this case, what we do is gonna be here. Okay, it's gonna be here. So it's gonna be here. Let's calculate. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3. 9 minus 3 is gonna be 6. 0, 1, 2, 3, 4, 5, 6. Yeah, it's here. That means actually I minus size is the numbers of non-zero. So numbers non-zero is this much. And then index for it. So 0, 1, 2, 3, 4, 5, 6. The index is 6. Actually, the number of non-zero 1, 2, 3, 4, 5, 6 is 6. That's why, yeah, it's here. So I just trying to be very clear to you guys, because sometimes we confused the index stuff. Okay, so here it's gonna be 3. Here is the 0, and then I plus plus. Here is 0. Then we as the size plus plus, and then I plus plus. Check this one is not equal to 0, so we swap this one and this one. So here is 2. Here is 0. And then I plus plus. When I plus plus, then here is equals to 0. The size plus plus. I plus plus again. Numbers I now is 7. 7 is not equal to 0. Then we swap this one. This one is 7. Here is 0. Okay, I advance and it's equal to 0. So we s plus plus, and then we check this one is equal to 0. Then size plus plus, and then we check another one. Here is 0. Then size plus plus, and then we check this one. It's not equal to 0. So now what we do? We swap the 2 with the 0. Okay, here is 2. Here is 0. Okay, and then I plus plus. And after I plus plus is equals to the length of the index of I now is equals to length of the names. So we stop the loop. Okay, this is basically the algorithm. Because we are doing in place. In this way, we are doing in place. Okay, so let's code. So for this problem, what we do? Int size equals to 0, and then we have a for loop. Int I equals to 0. Okay. Okay, let's continue here. Okay, let's continue here. So I equals to 0, and I smaller than numbers the length I plus plus. Okay, and then here if names I equals to 0, says plus plus. Here's I. Here's like this. Okay. Okay, so this one is the size equals 0. I start from 0 till the rightmost element here, and then we check if numbers I equals to 0. If numbers I equals 0, we size plus plus. Otherwise, we swap this one and this one. Okay, this is a for loop. Okay, and then we will write another loop to swap. Okay, 1 second. This will be here. Public void swap integer names int I int j. Okay, and then what we do, this is a temp. This variable temp equals to num I. So we do this because 1 second, like this I. J. So here we do this is the input for the swap is nums integer I and integer j. So first we define a integer is a int. So we get the value of nums I. We keep it temp, and then we give this nums j to nums I, and then we keep the nums I is here, right? So we use this nums I, give it to the nums j. In this way we can swap. Okay. For this problem, the time complexity for this problem is ON. Okay, because we just actually explored start from I till the end, and then we don't do any kind of other things. So it's gonna be ON. Okay, thank you for watching. I will see you next time.